Okay, welcome to the second voice recording. This one's going to be over ImageJ program. First thing we need to do is open up the file, and as you can see, I have opened up the file. This is for Carex abrupta, and it has all the tag information in the scanned-in image. You can see here that we're going to be measuring perigynia and achenes for this species. And here's the accession number. So make sure that everything matches up for you when you're looking at the specimen that you're looking at. Obviously, you've done all the herbarium measurements. You're going to be doing this on your own. So this stuff all needs to match up. One of the first things we need to do with ImageJ is set up our scaling. So you can see there's a clear ruler up here. It's in centimeters, so each one of the little lines is a millimeter. So we have to establish the proper scaling component so that all our measurements after this are accurate. So the first thing we're going to do is we're going to zoom in on the image. So we're going to click and zoom in, and then if things are out of whack, you can use the grab tool and kind of move up here. And I'm going to zoom in quite a bit just so that I can see those lines pretty well. And what you're going to do is draw a line from 1 centimeter to the other centimeter, and we're going to do it from the end of 1 centimeter line to the beginning of another centimeter line. This will give us the most accurate picture that we can get. Zoom in one more time here. And we're going to use the draw tool right here, use the line. We're going to start as close as we can to one side of the line, drag it across, and you can see with pixelated things, I don't know if you can see that there's little mini lines as I do a diagonal kind of vector. We want to keep it as straight as possible, so there should be no jaggedness in your line, all the way to the beginning of another centimeter line. Okay, and then we'll go into Analyze, and you can see here it says Set Scale, so we're going to set the scale, and we see a pixel distance here. Our known distance is this. We're going to set our known distance for 10, and instead of length in inches, because we don't use inches in science, we're going to use millimeters. And you can see here it says 28.7 pixels per millimeter. If you look in our protocol, we're trying to get 28.6. This says 28.7, so that's acceptable, I would say. I would say if you're somewhere between, I would say 28.4 to 28.9, I would say that's probably acceptable, but please ask your teacher to make sure that they agree with that. We're going to say OK, and now we're ready to start our measurements. So I'm going to zoom back out. And by the way, if you have clicked on the image, you can just do a Control minus or Control plus, and that'll do a zoom in, zoom out, just for a quick reference. So I still have the draw tool on right now. I'm going to grab and start looking around my petri dish here. You can see that there's a couple different things in here. There's perigynia, right, which have this teardrop look, and then up, usually at the top of the petri dish, you should see ones that don't look like perigynia. They're slightly different, and those are our achenes. So you can zoom in here, you can see how the achenes look a little bit different, especially in this one, compared to our perigynia. So there's a perigynia. Okay, so we're going to start off, we're going to do measurements of the perigynia first. Use our draw tool. We're going to measure not only the width, but we're also going to do the length. I'm going to get in as close as I can. All right, draw a tool. We're going to go across. We're going to do the width first. There. Really good. And we do Analyze. And we're going to do a measurement. Oops. The measurement pops up. You can see here, you're going to record this on your sheet of paper. And here it says length. Well, I just did width. Well, it doesn't know the difference between length and width. So that is your width number in millimeters. So 0.896 millimeters in width for the perigynia. We're going to do another measurement now. We're going to do the length. Go from, oops. We're going to go from the end here all the way up to the tip. And we're going to call that in for a measurement. And it pulls up the length now. So this is the actual length that you need to write down. So 2.884 and that's in millimeters again. So we have a width and a length of a millimeter. Now we need to do the next thing, which is going to be using a polygon tool, and this will get us the area and some of the other numbers that are valid. So we're going to use the polygon tool. Now the key with the polygon tool is to do as many dots as possible as you go around the perigynia. So I'm going to start over here, and I'm going to click my way around, and it will close the polygon once you come back to that original square that you see there that I started with. Try to keep it as close as I can to the shape of the perigynia. So I'm just clicking away as I'm going around here. If it seems like there's a little chunk taken out of the perigynia for some reason, then you could probably fill that gap and make it an approximation to what you think the shape should look like following the trend. If in doubt, take a screenshot of it. We can send it out to our specialists and they can answer that question for you. And I hope you all know how to do a screenshot. It's just Control Print Screen on your keypad. Take that, put it into Paint, some other device, and save that, and then send it an email to our specialist. Okay, so now I've done the polygon tool, I've gone all the way around. I'm going to analyze, measure again, and here is our results. And so it gives us a whole bunch of numbers, right? Follow the protocol and write down all the numbers that it needs. So we have the area here, you have the X and Y coordinates in it so that the scientists can look up what perigynia you're looking at if they need to check for precision, accuracy, circularity, and then obviously we have our width and our length. So we've just done the perigynia. So now we're going to, we can save these results if we want to. I'm going to move up to the achenes now and show you the achene measurement. Find it. If I can't find it, I'll zoom back out, which I'm going to do. There's my achenes. So I'm going to pick one of the achenes and obviously follow the protocol because the protocol does tell you how many perigynia and how many achenes you need to make measurements on. This one, excuse me, we're just going to do widths and lengths. So I'm going to zoom in one more time. I'm going to do a width here. Straight across. Try to keep that line nice and straight. Do the measure. Pulls up the width of my achene. And I'll do the length. Now, on this one, we're not going to go point to point. We're going to do it more to where the end of the achene rounds down to where the end of the achene rounds down to again over here on this side. And that's just because sometimes when the achenes are popped out of the perigynia, these pieces break off, right? So we're going to consider them a control piece if we don't use them in the data process. We'll analyze and measure that, and we get our length of our achene. So now we've done widths and lengths and areas of our different seed components. We're now finally going to do the last piece, which is to count all of our perigynia. And so in order to count perigynia, I think the easiest thing you can do is mark them as you go around. So we're going to use a little paint tool. And as we go around the petri dish, I'm going to zoom back in. As you go around the petri dish, you're going to want, you're going to want to mark these. Right? Grab, move around. So we've got one, right? We look here, this one looks busted open. So maybe this one that's busted open is one of our achenes up here, right? We'll have to keep track of that. We can mark it right now. So we've got 2. Keep moving around. No, this is debris, right? Scale pieces from the parts of the flower, the inflorescence that the spike that we pulled off. Here's another perigynia, so we're going to mark this one again. Mark. And then continue around our entire petri dish. If you have any questions with this, obviously read your protocol, ask your teacher, and we'll have the option to be able to ask scientists if you have questions about any of the measurements that go along with these images. All right, good luck. Email me if you have questions, or I'll see you in class. Thanks.